So we're starting out today with doing a few examples on slope. I'd like to go through these ones and say try these with you, because some of us don't quite understand how to do it. Just kidding. This was our plan. We were going to do some of this work together here. We went through 2 lessons yesterday, so I want to get some time on this one. So, take a look at this. First of all, what's this graph measuring? What's this graph measuring? What's it telling us about? Height of banana tree. Great. And let's just look at this initially. How tall does the tree start at in this graph? Wait, this banana tree? What do you think bananas are?
0.
No, what is the banana tree? Yeah, the banana tree. Yeah, certainly depending where you are, you'll see lots of them. It starts at 8. 0. Yeah. So taking a look there, now let's try to figure out, remember, how do we find slope of something? How do we find slope of something? Hello. Yes, someone just called me. He's not in class.
Not here.
He's not in class right now. So.
Not here, bro.
Yeah. So, in terms of finding slope, how do we find that here? How do we find orientation? Rise of red, nice. Brilliant. Okay, so we have a couple points we could use. We also could just figure out count the slope. It's fine either way. But we know slope is rise over run. Or we could say y2 minus y1 over x2 minus x1. Right, those are talking about the same thing. So usually, if you're wanting rise and run, you're kind of counting distance there, distance there. The thing to notice is that the scale isn't the same. On the x-axis, it's going by 1s. On the y-axis, it's going by 4s. So just keep that in mind. Yeah.
Why is it working?
Someone asked me an issue. I'm not sure what the reason was. I told you I'd look it up, and I never did. So I'll have to look later. Okay? It's an abbreviation. I don't remember what it's an abbreviation for. So rise over run or slope. Y2 minus 4. Well, let's pick some points. What's this point, Mari said this one's 0.8. How about this one here? How about this point here? I mean, you can pick any point. Sure, 2 and 16. So if we went y2 minus y1, 16 minus 8 over 2 minus 0. So we end up with 8 over 2. Our slope is 4. Now, one of the things we talked about yesterday was that there's also assumed to have units when we're talking about rate of change. We're talking about our units of y over our units of x. You can plug in so units of y over units of x. So this is measuring how many inches per day it grows. This is measuring it grows 4 inches per day. And you can use that rate to determine, how much it would grow in 10 days or how much it would grow in whatever. Yeah. I don't need to share there. No problem. So going up by 4 inches every day. Okay. So now figure out what's happening with this candle. Figure out how much it's changing each day here. That's all. That's all we're wondering. Right, exactly, good. I'm glad we recognize this is not super complicated. We're not reinventing the wheel here. Okay, so height of a burning candle is represented on this graph. So we're trying to figure out what the rate of change per day is. First of all, which is our independent variable? What's our x variable? What?
Time in hours.
That's time in hours, nice. And then our dependent, the thing that's changed.
Centimeters.
Right, exactly. Height in centimeters. And label the graph's axis. Well, it's already labeled, so that's pretty easy. Oh, sorry. Height, time, hours, height in centimeters. It's part of why I zoomed in, so that it's not so ugly. Now, what's the slope and what does it represent? Okay, slope. So we're going to pick some points. Maybe whenever I have a point that's starting at 0, I would use that. It makes my life easier. So this one's like the point 0, 10 height. Time and height. Maybe we should say that this is spelled out height. Time and height. Now what's the slope? First of all, we need to pick 2 points. 0, 10. Oh, this one's pretty nice. This one is 10, 0. I think that probably tells me something already about the height. But if the slope is y2 minus y1 over x2 minus x1, let's see. y2, that's the y value at the second point, so 0, minus the y value at the first point, 10, over x value at the second point, 10, minus the x value at the first point, 0. 0 minus 10 over 10 minus 0, negative 10 over 10 is equal to negative 1. So our slope is negative 1. And what does that represent?
Every 1 centimeter it goes down.
Right, every day or every hour it goes down by 1 centimeter. It's going negative 1 centimeters per hour. It is dropping by 1 centimeter per hour. Yeah, that makes sense. If you candle to bird for 10 hours, probably through your candle. That's dropping by 1 centimeter. Sure, fair enough. Oh, oh yeah, but just notice here. So this minus this. So y2 minus y1, 7 negative 1. Negative 3 over 2. Yeah. Emma asked a great question. This is going to be the most common issue. I'm actually going to color code this initially. Because I found we usually just kind of get confused with which one's which and which one goes where. So the big thing is the top is our y's. The top is our, I'll call them green here, and the bottom is our purple. The bottom is our x's. So it's the y's minus the x's. And the order really does matter. Now, you may have been confused yesterday because I said, well, it doesn't matter which one you call x1, y1, which one you call x2, y2. The way I usually do this, just to keep things straight, is I call the one furthest to the left point 1. Like this here, I would call x1, y1. This one here I'd call x2, y2. And the big reason it's kind of important to think through this is it really is important that in this formula, the one that's first stays first for both, the one that's second stays second for both. So like if this had been x2, y2, if this had been x1, y1, it'd be fine. But the math is usually a little bit easier if you work left to right. And also it's just really key that these points stay together and these points stay together in your formula. Yeah, so in this case the slope is saying it's decreasing by however much it's changing by. So in this case it's like every 1 hour it goes down by 1 centimeter. Cool. Okay, another one I want to look at. This one I have to do a bunch of the work on. So this tells me Lewis is driving on a highway 100 kilometers every hour. It asks me to draw a graph representing the distance traveled over the first 5 hours of the trip. Okay. So in general, something like this will go time as our x. Usually when you have time as a variable, use it as your x-axis. It's almost always your independent variable. And then we'll say distance traveled.
Wouldn't you go up by tens? Distance traveled.
I think I'll go up by hundreds. Because it's every hour it's going to go up by hundreds. Or maybe 50s. This is actually, the question Barack is asking is a really good one to think through before you do this. Like, okay, how big are the scales going to be? What am I going by? And in this case, I recognize every 1 hour, it's going to go up by 100 kilometers. So it's like, okay, if I go 1, 2, 3, 4, 5. I could do 5 hours. I'm going 2 drop blocks per, or I could just do every 1 block, whatever. Usually, I think the thing that makes the most sense is when you can do 1 square as like 1 unit. That makes good sense. So I'm just going to go 0, 1, 2, 3, 4, 5. And that usually seems reasonable. If you decide though instead to stretch it out and make it a little bit more space, it only asks to actually the first 5 hours, so maybe making it a little bigger is better so you can see more clearly. It's fine. And then distance travel, I'd do the same thing. I'd go 0, 100, 200, 300, 400, 500, and you could go on and on. The benefit of if you go larger, if you spread it out more, is you can see a little more precisely inside of the graph. The benefit if you make it smaller is you can extend it out more easily. Either of those is fine. Probably in this case, if I was thinking what was asked, it actually would have maybe made more sense to stretch it more. Maybe go like 50, 100, 150, 200, that kind of thing. But I'll go with what we've done. Going on. So now, the only info I was given was that it goes up by 100 kilometers every hour. So I need to start plotting some points. Okay, so starting at 0, we better start at 0. Now, after 1 hour, how far is it? Yeah, that's pretty straightforward. After 2 hours? Okay, and I can already see the slope that's happening here. So maybe I'll make a line. Maybe I'll play connect the dots. Something like that. Oh. Great. And draw an arrow on the end there. I'm going to put an arrow this way. Why didn't I put an arrow this way? Same reason as yesterday. It doesn't make sense to say he's traveled for negative 3 hours. Not a thing. And this actually said to represent the first 5 hours. So really, we can say that's for the first 5 hours. That's where the 5 hours ends. And then that's the title of the graph, label the axis. Haven't titled the graph yet. What should we title it?
Like the whole graph.
Yeah, what should we title the graph?
Lewis hours spent driving.
Sure. One thing I like what Baraka said there is he made sure he included both axes. That's fine. You could probably say like Lewis's trip or something like that. But I like when you include what's happening in both axes. It just makes the title a little more clear of what's happening. So like Lewis's, what did you say Lewis's?
Lewis hours spent driving.
Sure. Fair enough. But yeah, if I had titled this myself, I probably would have called it just Lewis's trip. Lewis driving. And from this graph, let's just ask a few questions this can tell us. First, let's interpolate. Let's go something within the data. If he's traveled for 2.5 hours, how far is he? 250, nice. What if he was to travel for 7 hours, which is a little beyond where?
Where is he going?
700 is driving to the American border. It's almost exactly 700 kilometers from here. He's trying to drive just into the States, buy a bag of bugles, and then come back. They like bugles, and Mountain Dew. What, you wouldn't do that?
I was no. Never mind.
Hey, yo.
If you were driving 700 kilometers to get to the American border, what would you be? I think it's actually slightly less than that. What would you be driving there to buy? You get some kind of snack.
With who?
You
I think Rock and you together.
Is there a snack that someone likes in the state that we don't have here? Just not funny. What?
I hope you're safe, bro.
Raising Cane's, that's a good call. Although it's a lot for the reason. There aren't any in the Western states. That's a pretty chicken.
What?
Raising Cane's?
Oh. Is that like drunk?
Maybe there is one here. I don't know. But there's not any. There's not any in the
Oh,
There is now. There's one of those.
Sonic Order.
Pardon?
Under rock, buddy.
It's a chicken restaurant. I've never had it until years ago. My sister lives in Ohio. What? Wingstop? Oh, there's like, I didn't know I never had it. No, I haven't. So guys, now you have a chance to do this. What you're doing is basically figuring slopes out and interpreting what it means. You're figuring slopes out, showing what it means. You'll notice for here today, I really just want you to get done to the end of here. Then we move on to more interpreting and reading graphs. For today, I'd like you to mainly work till the end of question 5 here. Yeah, do the homework. Question 1 to 5.
What's the hall? So when I heard things about this, I was like,